Welcome, ladies and gentlemen. Today we're going to talk about piecewise functions. So you're going to need your notes, a calculator, and a pen or pencil, please. Our learning objective today is that you are going to be able to take a piecewise function and evaluate for a specific x value. All right, so make sure you get that down in your notes, please. All right, just a couple notes I need you to write down. The first thing is, what the heck is a piecewise function? Well, a piecewise function is made up of pieces of different functions which are results of their different domains or their x values. All right? Now here's like a little in real life question. If we were thinking about piecewise functions in real life and how they obtain to us. At a job, you make $8.50 per hour up to 40 hours. After 40 hours, you make time and a half. At 40 hours, we switch the way we calculate our pay into a new function. So if we're going to look at this, we would use for our first function y equals 850x plus 40 hours or less. When we go over 40 hours, our new function is going to be y equals 12.75 because we get time and a half x for over 40 hours. All right, make sure you get all of this down, please. This next slide is 2. So here we have it written the same way, so you don't have to rewrite that. But if we're going to write it in math notation, this is what it's going to look like. We're going to have y equals, or sometimes instead of this y equals, ladies and gentlemen, we'll have an f of x or a g of x, okay? It's going to say 850x, where this means that our x value has to be less than or equal to 40. Our next equation would be y equals 12.75x, where x is greater than 40. So after we work 40 hours, that's the equation we'll work with. Now today what we're going to do is we're going to work with piecewise functions, and we're going to evaluate when we're given different x values. Okay, so you have to make sure you get this example down for me. Write down the function, and then we're going to find each one of these. The first one we're going to find is f of 5. So if we look at this 5, we're going to be looking at the second parts here, and here. 5 fits under this one right here, because 5 is greater than or equal to 3. So when we plug this in, we have f of 5 equals 1/2, and we're going to plug in 5 for x plus 1. So f of 5 equals 5/2, or 2.5, however you want to write that, plus 1. So f of 5 equals 3.5. And that's our answer when x equals 5. Next one we're going to look at is when f is -4. So -4 is going to fit under here, less than 3, so we're going to plug it into this one right here. So we have f of -4 equals 2 times the absolute value of -4 plus 4 minus 2. f of -4 equals 2 times the absolute value of 0 minus 2. So f of -4 equals 0 minus 2. f of -4 equals -2. So when my x value equals -4, my y value equals -2. Now this last one, we have to find it when f of 3. So it actually equals 3. Then we're going to come here. It's going to be this one because it's greater than or equal to. So we have to put f of 3 into our second equation here. So if I have f of 3 equals 1/2 times 3 plus 1. f of 3 equals 3/2, or 1.5 if you like to write it like that better. f of 3 equals 2.5. And that's our answer. When x equals 3, our y value is going to be 2.5. So this is how we're evaluating piecewise functions. We're going to plug it in. So we have one more example like this. So make sure you get this one down, please. Make sure you write down what f of x equals. We have 3 equations this time. We have 2x squared plus 1 if x is less than 4. We have 4x plus 2/3 if x is between 4 and 7, and then f of x equals 3 if f is greater than 7. So let's look at our first one. We have to find it when f is -2. So we're plugging in -2. Well, -2 is going to be less than 4, so I'm going to plug it into this one right here. F of -2 equals 2 times -2 squared plus 1. F of -2 equals, order of operations, we do exponents first. So it's 2 times 4, because -2 squared is 4, plus 1. F of -2 equals 8 plus 1. So f of -2 equals 9. And 9 is our answer when our x value is -2. Now if we look at f of 8, so it's going to be f of 8, so that's going to be here greater than or equal to 7. So when I have f of 8, it's just going to equal 3. I can't plug it anywhere else here, so this is my answer for that one. Last but not least, I have find it when f of 4, so when it equals 4. So here I have x is equal to 4, so I'm going to plug it in on this one. F of 4 equals 4 times 4 plus 2/3. So f of 4 equals 16 plus 2/3. So when x equals 4, I get 16 and 2/3 for my answer. There we go, ladies and gentlemen. There's our second example. Make sure you got all of that down, please. And now we're going to move on to our last example, which is a little bit different. I give you the graph, and then you have to tell me what my y value is. So make sure you get this graph down exactly the way you see it, please, because you're going to have it exact to be able to look back at it. Now we're going to go through and we're going to find this. Our first one is f of -6. So when my x is -6, so I'm right here, what is my y value? So if I go up, I'm going to run into this right here. My y value is 5. So when it's f of -6, it equals 5. Do the same thing when my x value is 1. Come here, here's 1. Now this one, look, it meets here and here, but we have to use the one where it's filled in. That means it includes that. So it's going to equal 3 when we go across. And our last one we have is find it when f is -1. So my x value is -1. We're right here. If we look here, we have 2 answers. Excuse me, just one, sorry, because this is our line that we drew in. We have one answer. We can go down here, f of -1, and we end right here. We end at -7. Right? So make sure you get down all of these examples, ladies and gentlemen. And that's all I have for you today. So I hope you go out and have a wonderful day. And I'll be seeing you soon. Bye.